In this video, we're going to take a look at MPLS L3 VPN with Managed CE. Now, when it comes to Managed CE, this is one of those things where if you have a situation where you've got a customer that is buying MPLS service from you, whether it's L3 or L2, it does make a difference because typically in L2, you're not leveraging, or you absolutely could do a CE router that is doing layer 2 connectivity back to the provider core. But typically I see this with L3 VPN more than I see with L2, but it's still applicable to L2 as well. So basically what the service provider does is it uses the network management VPN to manage the CE routers of all VPNs. Now you might say the network management VPN. Well, it really depends on the situation. Some service providers that I work with, they have their own dedicated management VRF, and they allow, they have this specific VRF, which is they leverage. In the previous video, we talked about Central Services VPN, right? So we talked about how you can go through and have, you can export certain route targets, you can import certain route targets, you can use the import map and export map with the extended community values, which gives you that leverage of being selective as to who and what you allow traffic to talk to. The capability of the managed CE, and it depends on how the provider rolls it out. Some providers will just allow you to jump in through the VRF. They'll say telnet VRF XYZ or SSH VRF XYZ and then the IP address, and you just jump into the router and away you go. It really depends on the situation. There's multiple ways of getting it done. At the end of the day, it's really up to how you want to do it. So what is the point, right? What is the point of Managed CE? Well, Managed CE is the most common rollout that I see of MPLS for any size provider, whether it's a managed services provider, whether it's an ISP that's you're purchasing L3 VPN service from, regardless of the business use case. It's really irrelevant. What it comes down to is you've bought the service from the provider sends you a customer premise equipment or CPE. Once that gear comes on site, your job is to get that equipment racked, powered on, and in place so that the provider's circuit can come in and plug into this box. Okay, once that's in there, you're good to go. All of your very large L3 VPN providers that are out there, I won't mention names, but you know who they are. Most of them do this. Whether it's they're dropping off a Ciena box, whether they're dropping off an ADVA box, whether it's a Cisco box, they normally all terminate the same type of device. Well, or the same style device, I should say, where it's a managed CE. They take care of everything. You physically plug into their network, and then you just send everything up to them. They know how to reach you, and everything is good. They don't have to sit there and do hardly anything. What the managed CE, for the most part, does is it's them connecting to the box. How they connect to it is irrelevant. Whether they use SNMP via like SolarWinds or PRTG or some sort of, most providers I work with use PRTG. Regardless of how they do that, there's so many different ways of doing it. It's pretty much up to them on how they go about doing it. So basically, this also allows the network management server to access the loopback of all the CEs, which allows me to keep track of. And let me ask you a question: why loopback and not the physical interface IP? Any ideas? Well, the main reason is if you can connect to the loopback, you know the router is more than likely up, because it is possible for the circuit to be down. And I've had a lot of providers that I work with. They will leverage L3 VPN on the front end, and oftentimes more and more providers are giving you the flexibility of using some sort of backup connectivity. You know, they might give you a DMBPN type circuit. If you have an internet circuit and you have managed CE, they'll allow you to gain, especially if you deal with service providers that you're using for more than just internet access or L3 VPN access too. If you're using that provider in for a solution where you are providing maybe hosted services of some type, maybe they're doing hosted voice over IP or hosted web or some sort of database replication. If you're leveraging the provider for more than just internet or L3 VPN service to other sites, that's another option they have. DMVPN or IWAN or some sort of other technology or technique, maybe ASA, site-to-site VPN. Regardless of the method, oftentimes that's what you're doing as a backup service if the provider is a content provider of some type. Like I said, hosted web, voice over IP services, things like that. If that's not the case and you're just leveraging the provider for L3 or internet services, typically you're not going to have that same level of care, but it really depends on the situation. So because of the fact that this is similar to central services and simple VRFs, it does give us a lot of capabilities to use centralized services. So just like we talked about in central services, I can be on a central services server, and then because of the fact that I will have reachability in your VRF to reach whatever, you could think of Central Services VPN as a variation of, I'm sorry, Central Services VPN as a variation of the overlapping VPNs, because I have had quite a few customers where they'll have their own dedicated connections to like a central location, like the hub and spoke type of a network. Well, they'll have full reachability, and then you'll do some sort of selective VRF import, and you'll be able to have reachability. Maybe there's an import and an export to where you're importing and exporting routes, and you have a third-party provider that is doing some sort of management for you. Whatever it is, it doesn't make much of a difference. At the end of the day, it's usually application management and monitoring, and whatever that application is, normally the provider doesn't care. As long as the reachability is there, you're good to go. So that also could mean where the engineers like myself will simply SSH or telnet into the router and do whatever connectivity that they need to. Maybe they need to change a configuration option, or maybe they're troubleshooting something. One of the big benefits to managed CE routers that comes into play that goes beyond just that is the fact that when oftentimes I've experienced engineers working for the customer may not have the technical depth to be able to set up BGP. Maybe BGP is not something that those engineers are familiar with. Maybe you have a customer that has a bunch of systems engineers that deal with Windows, VMware. Maybe they're email engineers. They're not network guys, so they don't have that network background, and they'll be quote unquote guessing on how to get things working. Anybody can Google how to configure a BGP for a router. It's an open standard protocol, so the configurations are out there. Or they can come to INE and they can learn how to do it themselves. But sometimes you don't have the technical staff to do that, so you're relying on the provider to do that. Well, you're relying engineers like myself to configure BGP, get it up and running, get the peering to go, and then get the connectivity to point A to point B. So at the end of the day, managed CE routers allow the provider to have much more granular control over what comes into the network. So we can go in there and say, all right, we're going to allow you to send us, say, 150 routes. You can't send anything more than that. We recommend you summarize wherever you can and go from there. So you can put certain contractual SLAs in play, which will help with the provider, will help with the scaling of the provider network. And you might say, well, why would that become a problem? Well, I've had to deal with customers that will send me hundreds of thousands of routes. And I mean hundreds of thousands. They might have, that's a very rare use case, but a more conservative number would be more like 10,000 routes. I've had customers send me that many routes. Well, that's quite a few routes. And if that's the case, BGP can scale to that level, yes. However, at the end of the day, if I've got 1,000 customers hanging off that provider edge router, and each one of them is sending me 10,000 routes, you do the math on that, that's a lot of routes. So rather than just allowing the customer to send in any arbitrary number of routes per VRF, I can limit that down to say, I'm going to limit you down to 1,000 routes, and I have 1,000 customers. Well, that's a lot. That's still a lot of routes, but it's a lot less than having them drop you to overload the device. Typically, your PE devices are going to be rather robust routers, like an ASR 1006 or maybe even an ASR 9K. So or CRS. So at the end of the day, it's up to you on how far you want it to go. So a lot of flexibility, lots of capabilities and options. It's up to you and how you want to roll that out. But that's basically how it works. There's really no demonstration that I can go through here because a lot of this stuff has already been covered in central services and inside of overlapping VPNs. That's kind of the point of those two. This is one of those specific roles that, or the type of role that that particular device will be filling, and it's leveraging central services or overlapping VPN route target import export policies and things like that that are going to take that into consideration. So not so much of a configuration thing. There's no like manage CE command or anything like that. It's more of how you have the device rolled out and who has access to it, things like that.